Throughout humanity's attempt to understand life on Earth, there has always been a quiet assumption that no creature could be larger than blue whale. At over 30 meters in length and weighing close to 200 tons, equivalent to more than 30 African elephants combined, it exists at a scale where biology begins to touch the limits of physics. A body that large should not function smoothly. On land, it would collapse under its own weight. Even in water, every system is operating near its maximum threshold. And then, hidden within a few scattered bones, a contradiction appears. A jaw fragment so large it suggests a creature that could approach, even exceed, that scale. No complete skeleton, no definitive answer. And just enough to suggest a possibility that there was once a time when something crossed that invisible boundary and somehow still existed. But if that is true, then what exactly was that creature? The shock is not that something rivaled the blue whale. It's that it may have done so with almost no trace. The largest animal alive today, the blue whale, reaches over 30 meters and nearly 200 tons, a living boundary where biology meets physics. And yet, from a single massive jawbone found along a quiet shoreline, scientists inferred the existence of Ichthyotitan, a creature of similar, perhaps greater scale. Not a mammal, not even a whale, just fragments and a question. How many giants have we already missed? To understand why the blue whale matters, you have to see it not just as an animal, but as a boundary. At over 30 meters long and reaching close to 200 tons, it exists at the edge of what biology can sustain. Every heartbeat pushes tons of blood through a body that should not, by simple logic, function so smoothly. On land, a creature of that mass would collapse under gravity. But in water, buoyancy lifts the burden, allowing size to stretch further than it ever could above the surface. Even so, there are limits: metabolism, oxygen, energy. The blue whale does not break these rules. It lives exactly where they begin to resist. And then, almost quietly, something interrupted that certainty. Along a stretch of coastline in England, a fossil emerged. Not a skeleton, not a body, just a fragment. A jawbone. Massive, disproportionate, carrying a scale that did not quite belong to anything known. From that single piece, paleontologists began to reconstruct a presence now referred to as Ichthyotitan, a marine reptile, not a mammal. Not built like a whale, yet somehow approaching its size. But here is the unsettling part. This conclusion comes from almost nothing. No complete skeleton, no clear lineage, just geometry, comparison, and inference. It raises a question that lingers beneath the data.
Excellent.
Are we discovering this animal, or are we trying to remember something we were never meant to fully see? When people ask what the largest animal is, they often imagine length, a body stretching across distance, something that dominates space simply by how far it extends. But biology does not measure greatness that way. A creature can be long and still be fragile, thin, almost insubstantial. The real measure is mass, the total weight of living tissue, either the density of existence itself. A 30-meter body made of muscle and fat is not the same as 30 meters of something narrow and hollow. Mass is resistance. It is inertia. It is the difference between something that occupies space and something that defines it. And when we begin to look at size through that lens, the hierarchy of giants starts to shift in ways that feel almost counterintuitive. Consider the Argentinosaurus, often described as one of the longest animals to ever walk the earth. Its body could stretch beyond 30 meters, a moving bridge of bone and muscle. But much of that length was air, neck and tail, extended but not dense. Its total mass, while immense, likely reached only a fraction of what the blue whale carries within a shorter, thicker frame. Or take the bootlace worm, capable of reaching even greater lengths, but yet weighing almost nothing in comparison. These examples reveal something subtle but important. Size is not a single dimension. It is a balance between scale and substance. And when that balance shifts, the idea of what it means to be the largest begins to fracture. At first glance, the numbers seem clear. The blue whale can reach up to 200 tons, with the largest recorded individuals approaching 209. In comparison, estimates for Ichthyotitan suggest around 80 to 120 tons. It sounds definitive until you look closer. That 200-ton figure is not typical. It represents the extreme upper limit, not the average. Most blue whales fall closer to 100 to 150 tons. And Ichthyotitan? Those numbers come from fragments, 2 jawbones, scaled through comparison and assumption. We are not measuring the animal itself, only reconstructing it from absence. So what are these numbers really? Data points, or educated guesses shaped by what little we've managed to find? At first glance, it feels almost like a mistake. How could a reptile resemble a whale? But evolution does not follow identity, it follows function. In the open ocean, efficiency becomes law, and bodies begin to converge toward the same solution. The Ichthyotitan, though distant in ancestry, likely carried the same streamlined form seen in the blue whale, or even sharks. A tapered head, a powerful tail, a body shaped like a living torpedo. This is convergent evolution, not imitation, but necessity. Different lineages, separated by millions of years, arriving at the same design, because physics leaves them no other choice. Size does something subtle to life. It changes how it experiences the world. For massive marine animals, heat is no longer something easily lost. Instead, it becomes something held, stored, almost preserved. This is gigantothermy, a quiet advantage of scale. A body the size of the Ichthyotitan would not cool the way smaller reptiles do. Its sheer volume slows the escape of heat, turning it into a kind of living thermal reservoir. In colder, deeper waters, where most reptiles would fail, size becomes a shield. Not through speed or strength, but through inertia, temperature resisting change, just as mass resists motion. Long before modern oceans settled into their current balance, the seas of the Triassic were something else entirely, unstable, recovering, and strangely abundant. In these waters, food was not scarce. Giant cephalopods drifted through the depths, large fish moved in dense populations, and marine reptiles occupied niches that would later disappear. For a creature like Ichthyotitan, this was not just a habitat, it was an opportunity. Size demands energy, and energy was everywhere. More importantly, there were no true giants yet to compete at that scale. No whales, no modern apex systems. In that brief window of time, the ocean did something unusual. It allowed a single lineage to grow without restraint. It did not end slowly. Around 201 million years ago, the world shifted with a violence that did not need to be seen to be felt. The Central Atlantic magmatic province tore open vast regions of the Earth's crust, releasing enormous volumes of lava and, more critically, carbon dioxide. The atmosphere thickened, temperatures rose, the chemistry of the oceans began to change, becoming more acidic, less stable. Life did not vanish in an instant, but the systems that sustained it began to unravel. Food chains weakened, then collapsed. And in that unraveling, the largest organisms, those that required the most to survive, were the first to face a world that could no longer support their scale. For something as vast as Ichthyotitan, survival was never passive. Every hour, its body would have demanded an immense and continuous flow of energy. Millions of calories just to maintain balance, movement, and warmth. When the oceans were full, that demand was sustainable. But when the system began to fail, size became a liability. Smaller animals could adapt, shift diets, reduce their needs. Giants could not. They were locked into their own scale, unable to shrink fast enough to survive the collapse around them. In that moment, mass stopped being an advantage. It became a trap, one that required more from a world that no longer had enough to give. And then, for an astonishing stretch of time, the ocean grew quiet in a very specific way. For nearly 200 million years after the fall of giants like Ichthyotitan, nothing in the seas reached that same overwhelming scale. Marine reptiles returned, diversified, dominated, but none approached that threshold again. It was as if evolution stepped back, recalibrated, chose a different path. Only much later, when mammals re-entered the ocean and became creatures like the blue whale, did that scale reappear. The question is not just why giants vanished, but why it took so long for anything to replace them. For a long time, the evidence was there, just not understood. Along the coasts of England, fragments of enormous bone were recovered and catalogued, then quietly set aside. They were too large to fit neatly into known classifications, too incomplete to inspire confidence. One such specimen, later linked to Ichthyotitan, remained in a kind of scientific limbo for years. Not dismissed, but not accepted either. It is a pattern that repeats in paleontology. Discoveries do not always arrive fully formed. Sometimes they appear as anomalies, objects that resist explanation until the right context emerges. The unsettling part is not that we missed it, it's that we may still be surrounded by pieces we have not yet learned how to see. Long before these bones were understood, there were accounts, quiet, scattered, often dismissed. Sailors described immense shapes moving beneath their vessels, forms too large to identify, too brief to confirm. Along certain coastlines, reports surfaced of massive carcasses washed ashore, their proportions distorted by decay, their origins uncertain. At the time, these observations were folded into folklore, absorbed into the language of sea monsters and myth. But in hindsight, some of those descriptions feel uncomfortably familiar. Not precise, not reliable, but not entirely impossible either. When fragments of Ichthyotitan began to surface centuries later, it raised a quiet question. Were those early witnesses imagining something unreal, or struggling to describe something they had no framework to understand? There is a moment in every discovery where explanation hesitates, where evidence exists, but meaning has not yet caught up. The boundary between science and myth is not a line, it is a gradient, is shifting as knowledge expands. Creatures once feared as legends, giant squids, deep-sea predators, even early accounts of the blue whale, were, at one time, dismissed as exaggerations, not because they were impossible, but because they arrived before understanding did. The same tension lingers around Ichthyotitan, a presence inferred from fragments, hovering between certainty and speculation. It is not that science rejects the unknown, it simply requires that the unknown wait, until it can be seen clearly enough to be believed. The human mind does not tolerate uncertainty well. When faced with incomplete information, it does not remain neutral. It fills the gaps. Shapes become patterns, shadows become intentions, and the unknown is given form. This is not a flaw, but a survival instinct. In vast, featureless environments like the ocean, that instinct becomes amplified. A distant movement, an unidentifiable mass, a fleeting silhouette, each can be transformed into something more. Not because it is real, but because the mind needs it to be. And once imagined, it becomes difficult to unsee. Stories do not travel unchanged. They expand, bend, and gather meaning as they move from one voice to another. Along coastlines and across generations, accounts of the sea became narratives, shared, retold, reshaped. What began as an observation could become a warning, then a legend. Details grow sharper in memory, even as their origins fade. In this way, the ocean accumulates stories the way it accumulates depth, layer by layer. Some of those stories echo real encounters, distorted over time. Others emerge from fear itself. and once they take hold, they persist far longer than the events that inspired them. Science does not move at the speed of discovery. It moves at the speed of verification. For creatures like Ichthyotitan, that gap can stretch across decades, even centuries. Evidence may exist, observations may accumulate, but without enough data, certainty remains out of reach. The ocean, vast and difficult to study, only deepens that delay. What we know is often limited not by what exists, but by what we have been able to observe, measure, and confirm. So what, then, is the true limit of life? The blue whale stands as the largest creature we have ever measured, a living confirmation of how far biology can stretch without breaking. And yet, the shadow of Ichthyotitan lingers, a presence inferred, incomplete, hovering just beyond certainty. We know it existed. We know it was immense, but we do not know if it was the exception or part of a pattern we have barely begun to see. Because the deeper truth is not that giants once ruled the ocean. It is that we have only uncovered fragments of their existence. The fossil record is not a complete archive. It is a scattering of clues. And if something larger had lived, grown, and vanished before leaving a trace, would we even know to look for it? Perhaps the limit was never crossed. Or perhaps it was, quietly, briefly, and then forgotten by everything except the silence beneath the sea.